An epic war has raged between the evil White Wizard and the helpless T-Squires. A battle that has endured since the dawn of time itself. Well, actually, HIV's only been around for about 50 years. It only made its way to the US in the 1980s.
Guys, no, don't take my deep voice away. Damn. Back to normal. Okay, let's get started. The battle I'm referring to is none other than the one against HIV, represented here by this White Wizard. HIV, which is also known as human immunodeficiency virus, is a member of the lentivirus genus, which is part of the Retroviridae family. All members of this family are retroviruses, and HIV is no exception. And I'll come back to exactly what this means in a bit. The vast majority of untreated HIV infections eventually develop into AIDS, or acquired immunodeficiency syndrome, which, like the name suggests, is an immunocompromised state. So notice our wizard wields power through this crutch-like staff. This, of course, is a recurring symbol for immunocompromised. There are, in fact, two types of HIV, HIV-1 and HIV-2. HIV-1 causes the majority of infections worldwide in nearly all cases in the U.S. So HIV-1 is scary and virulent, just like our HIV wizard. On the other hand, the wizard's henchman is less scary, just like HIV-2. HIV-2 is really only prevalent in certain regions of the world, including West Africa, Portugal, Spain, and India. HIV-2 is also less virulent, which translates to lower levels of virus in the bloodstream. As a result, HIV-2 is less infectious and leads to a slower decline in immune system function. We'll focus on HIV-1 for most of this discussion. HIV is a single-stranded RNA-positive virus, so notice the warm orange hues, which of course represent an RNA virus, plus the positive sense sun. As I mentioned earlier, HIV is a special kind of RNA-positive virus. It's a retrovirus. This means the virus converts its RNA to DNA by an accompanying enzyme, reverse transcriptase, or, in the wizard lingo, reverso transcriptum.
Reverso transcriptum.
Yes, thank you, wizard. The resulting DNA intermediate is then integrated into the host cell genome, where it replicates along with the host DNA, which is why, as you can imagine, it forms a chronic disease, and how it became known as a slow virus, or a lentivirus. So let's move on to the structure of the HIV virion. At the very core, you've got the genetic material, and HIV has a diploid genome, meaning each virion contains 2 copies of positive sense RNA. See the 2 orange dragons at the very center of the wizard's cap? Well, they're orange because they're RNA. The RNA strands and their accompanying reverse transcriptase are surrounded by a conical, i.e. cone-shaped, capsid, hence the wizard's cone-shaped hat. Before I go on, I have a little disclaimer. I'm going to be talking about a lot of different proteins, all with letters in front of numbers, like GP120, GP41, P24, and so on. Unfortunately, the structure of HIV is something that's often tested. Normally, these are exceptionally tedious to try to remember, but luckily, you have Sketchy. This kind of stuff is our bread and butter, so don't worry, we'll make this memorable for you. There are 3 broad categories of proteins that we'll be learning for HIV, and we'll go into more detail about these in the next video. And the categories are GAG, or group antigen proteins, POL, for polymerase, and ENV, for envelope proteins. Luckily, we've already knocked out one category, and that's POL. And the only protein you need to remember for POL is reverse transcriptase. GAG proteins are associated with the viral capsid, or the inner shell of the virus. The capsid is composed of multiple subunits of the P24 protein. To remind you that P24 is associated with the capsid, we've drawn this sundial design on the brim of the wizard's hat. 24 hours in a day for P24, and just as the brim surrounds the wizard's conical core hat, so too do these capsid proteins surrounding the core. The capsid itself is surrounded by another layer. Next comes an interwoven matrix that connects the core to the envelope. Here, you'll find the P17 matrix protein. Our wizard has come prepared for battle. protected by a chainmail undercoat and a dagger and sword combo that form the number 17. Remember, the chainmail undercoat is to remind you that the P17 matrix proteins are beneath the viral envelope. Directly overlying the P17 protein shell is the envelope, which is why our wizard is enveloped in a large robe. The envelope is composed of a lipid bilayer studded with glycoproteins. These ENV proteins, or envelope glycoproteins, are actually complexes of two glycoproteins, or GPs. There's GP41 and GP120. Both exist as trimers, and we're going to represent both on a pipe. GP41 is a transmembrane protein, so we have 41 here on the stem, or the mouthpiece of the pipe, and if you think about it, a mouthpiece is technically transmembrane. Notice for the pipes in his pocket, the stem reaches deep into the pockets of his robe, just like a transmembrane protein extends deep into the membrane of the envelope. GP120 is the outer glycoprotein that will eventually come in contact with host receptors. So we've incorporated a 120 into the outermost part of the pipe, which is the bowl. And just so you never forget this, there's another reason we represented these numbers on a pipe. Because if you remove the ones, then you have 420. 420 is, of course, the internationally recognized Weed Day. So I think having 420 inscribed on a pipe is pretty fitting. HIV specifically targets the host's CD4 positive immune cells, which includes both helper T lymphocytes and macrophages. So notice the wizard's about to face off against this helper squire who has a 4-shaped strap incorporated into his outfit. He represents CD4 positive T lymphocytes, also known as helper T cells. And it's no coincidence that HIV targets CD4 positive immune cells. As it turns out, the primary receptor for HIV is CD4 on the host cell's surface. In order to gain entry to the host cell, HIV must also bind a co-receptor from the chemokine receptor family, either CCR5 or CXCR4, represented by a CCR5 banner and a CXCR4 flag. CCR5 is associated with T cells and macrophages, while CXCR4 is primarily found on T cells. Generally, HIV is tropic towards one of the two co-receptors, meaning it has a preference for one or the other. Strains of HIV that use CCR5 co-receptor are known as R5 viruses. These predominate early in the course of HIV infection. We know that CCR5 binding is an important virulence factor, in part because we've seen some individuals with CCR5 gene mutations that make these individuals virtually resistant to HIV. They can maintain normal CD4 counts and don't progress to AIDS. This is why the CCR5 co-receptor is an important therapeutic target. But more on that later in part 2 of our saga. However, the majority of hosts are susceptible to HIV's ability to enter the cell through binding the CCR5 co-receptor. And, like other viruses, HIV has developed the ability to acquire new virulence factors that enable its entry into host cells. In fact, later in the course of infection, some HIV strains acquire the ability to use CXCR4 as a co-receptor. Those that exclusively use CXCR4 are known as X4 strains. Some strains can actually use both co-receptors and therefore are known as R5X4 viruses. Let's move on to transmission. It's no surprise that HIV is transmitted through body fluids, represented here by the wizard's set of potion bottles. The red one's easy. HIV is a blood-borne pathogen, so exposure to infected blood is a risk factor, whether in the form of IV drug use, or with shared needles, or as an accidental needle stick. HIV can also be transmitted through blood and organ donation. Fortunately, broad screening practices have reduced the risk of transmission in these cases to a very low level. HIV is, of course, also transmitted sexually, hence the less colorful potions, which represent semen as well as rectal and vaginal fluids. HIV can also be passed from mother to infant, and this is known as vertical transmission. This can occur during pregnancy, as the virus can cross the placenta, but it can also occur during labor and delivery or through breastfeeding. And I don't want to know what this wizard's going to be doing with these body fluids. So, once a person's infected with HIV, the disease progresses through a series of stages. Watch out. Unfortunately for the squires, the wizard's firing off bolts of orange and blue magic. Fortunately for us, these brilliant magic beams illuminate some key points. The orange beam of light represents the level of HIV viral RNA in the plasma. We're talking HIV's positive sense RNA genome, so the magic beam is similar in color to the positive sense sun. This RNA level is also known as the viral load. The blue beam, on the other hand, represents the CD4 T cell count, and you'll notice it's taking out a poor helper T squire. Initially, HIV replicates unchecked because the host's immune response has yet to fully develop a response. The result is a rapid increase in viral RNA. And this is accompanied by a decline in the blue CD4 T cells, at least temporarily. During this early stage, many patients develop symptoms of acute HIV infection, also known as acute retroviral syndrome. This presents with a cluster of nonspecific symptoms, sometimes described as mono-like or flu-like, and the most notable is fever and fatigue. Take note of this recurring feverish flame helmet, and pay attention to where this vile creature is standing, namely, right below that early spike in viral load. The symptoms typically resolve on their own within a few weeks, thanks to a robust immune response, including the production of anti-HIV antibodies, which neutralize circulating virus, leading to an overall decrease in viral load. After this initial acute phase comes a long asymptomatic period known as clinical latency. This lasts around 8 to 10 years, or around a decade. Check out this book's location. It's above where that orange annihilation beam has somewhat flattened out and hasn't shot up again yet. This is because the host's immune response is keeping the viral RNA in check, to some degree. But only to some degree, because HIV is also doing its darndest to destroy CD4 helper T cells during this time. So the book is also above where that blue death ray is slowly decreasing, but hasn't totally tanked. But unfortunately, all things must come to an end, including clinical latency. By this point, the CD4 count is starting to tank, and it's not a coincidence that this is when the viral load starts to drastically increase. Notice how the blue beam is attacking the squire on the floor, while the orange one takes a sharp turn upward. So, by now, the wizard has quietly plucked off one helper T squire after another, until the squire T cell army is too small to mount an effective immune response against it. And that's how the wizard creates the immunocompromised state known as AIDS. And to be technical, there are two ways to diagnose AIDS. The first is based on CD4 counts alone. Anything below 200 is, by definition, AIDS. The presence of an AIDS-defining illness is the second way to diagnose AIDS. These tend to start occurring around a CD4 count of about 200 anyway, but not necessarily below 200. So what exactly is an AIDS-defining illness? Well, these are characteristic syndromes that occur as a result of immunosuppression due to the depletion of CD4 T lymphocytes. Many of these illnesses are opportunistic infections, including fungal, bacterial, viral, and protozoal infections. Basically every type of infection. Hence, basically every type of lantern hanging from the shelf. Certain malignancies can also be AIDS-defining. These are often mediated by an oncogenic virus like EBV, HPV, or HHV8, the virus that causes Kaposi sarcoma. Normally, an intact immune system prevents these viruses from causing malignancy. However, the chronic immunosuppressive state from AIDS allows them to run wild. As you travel a sketchy universe, you might come across an AIDS ribbon here and there. This represents an AIDS-defining condition. Alright, hang in there. We're finally on to testing for HIV. Screening for HIV typically starts with the 4th generation test. This can detect the presence of HIV 1 and 2 antibodies and the HIV P24 antigen. That's why this elven archer is decked out in a combo of 1 and 2 antibody arrow quivers and a 24 sunburst dial. The test is positive if either antibody or antigen is detected. If the 4th gen test is positive, the next step is an antibody differentiation immunoassay. In most cases, this will confirm the presence of antibodies and differentiates between HIV-1 and HIV-2. Notice the two different antibody eras? Well, this is here to remind you that this follow-up test can differentiate between the two. But what if the 4th gen test is positive and the follow-up antibody tests are negative? You guessed it. Detection of P24 antigen is likely responsible, and furthermore, the person likely has acute HIV infection. That's because antibodies need time to develop. So there is this so-called serologic window between infection and the appearance of antibodies several weeks later. But certain tests that detect pieces of the virus become positive earlier on. This includes the P24 capsid protein, as well as viral RNA itself. So, acute HIV infection can be confirmed with HIV RNA nucleic acid testing, also known as NAT or NAT. This swarm of NATs, next to the positive sense RNA sun, are here to remind you that NAT or NAT is used to detect HIV RNA. Alright, that wraps up HIV Part 1. Check out the sequel for all you've ever wanted to know about the virus's life cycle and treatment options. Shh, do you hear that? The beacons are lit. The trumpets are blowing. Elfavir calls for aid.